Hey, hi, good morning, everyone. Okay, let me share my screen. Just 1 minute. Just 1 minute. Okay, so last time we were discussing probabilities. In probability, and let me know if my voice is not clear. I'm using a different headphone this time. So,
It's clear.
right. So, we were discussing probability, and the foremost important thing in probability to understand is that the probability will always vary between 0 and 1, right? So the maximum probability of something can be 1. The minimum probability of something can be 0, right? So the probability cannot be negative. Similarly, it cannot be greater than 1. That was the first rule that we had. The second rule of probability was complement rule. What complement rule says? Complement rule says that probability of not A, probability of something not happening is same as 1 minus probability of that thing happening. Okay, so probability of not A is equal to 1 minus probability of A, right? This one. Yeah. Similarly, the other rule that we discussed was the probability of A or B. Like the probability of either A or B happening is probability of A plus probability of B, 1 minus probability of A and B. So that thing we tried to prove through this diagram, right? We said that if I will assume this whole thing to be probability of A. Just 1 minute. If I'll assume this whole thing to be probability of A or B, right? Then we can see that this whole thing is made up of this one part, second part, and this third part. What is the first part? First part is nothing but A minus A and B. What is second part? Second part is A and B, where both are happening. Like there's an overlap. In this region, there is an overlap. Okay. So what is this overlap is called? The overlap will be called A and B. And what is the third part? Third part is nothing but the whole B minus A and B, right? So the first part is A minus A and B. Second part is A and B. Third part is B minus A and B. Okay. And if I will rearrange this, it will become A plus B plus A and B, right? Let's say this is the A which is coming here. This is the B which is coming here. This is the A minus A and B and A and B. Like twice we are subtracting it. So it is here, right? And then let's say this one. This plus A and plus AB you can see over here. Okay. So if I will rearrange it, what we will get? We will get A plus B. And if you will solve this, we will get minus A and B. Right? So probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Okay. Then one more rule that we were discussing was there was this addition rule, right? The sum of all probability of all possible outcomes is equal to 1. The rule of addition. But for this rule to hold true, there are two conditions that we should be able to meet. First condition, that the events should be mutually exclusive. Okay, the event should be mutually exclusive. If it means that if one event is happening, the second event cannot overlap with it. Okay. So for example, here, right, probability of greater than equal to 3 and probability of less than equal to 3. These are not mutually exclusive. Why they are not mutually exclusive? Because there is a 3 which is overlapping in the first condition also and in the second condition also. Okay. What is collectively exhaustive mean? Collectively exhaustive means that together they will satisfy all the possible outcomes. For example, in first one, together they were not able to cover all the outcomes. Why? Because 3 was not covered either in the first or in the second probability. Okay, so when both these conditions, mutually exclusive and collectively exhaustive, will get satisfied, only then uh, this sum of probability equal to 1 will be true, otherwise it will not be true. Okay, and then in the last, we were discussing probability of A and B equal to probability of A multiplied by probability of B. And this is for independent events, the events which are independent of each other. So I believe this is the question that we solved for that. Probability of having AC in the car is 20%, and probability of car being black in color is 30%, right? And let's assume there is no relation between having a AC in the car and the color of the car. Okay. Like whether it's not like the color, if the color is black, then there will be high probability of having AC in the car. Nothing like that. So color of the car and AC in the car is two independent events here. Now someone is asking you, what is the probability that the car is black and has AC in it? Okay. So probability of a black car and a AC car, right? The same thing. The car should be black. At the same time, the car should also have AC. What is the probability for that? Because these are independent events, we can say probability of black car multiplied by probability of AC car. It will become 6%. Now, okay, let's do one more question.
Can you explain me the third point, sir?
Third point.
In the slide. Um,
Which slide?
yeah, this one, probability tools.
This one? This one?
Yeah, yeah, yes.
Right. It's as simple as that. If let's say there's a match happening between India and Pakistan, right? If someone will ask me what is the probability of India losing, okay, which is same as what is the probability of India not winning, right? So if let's say in India Pakistan match, India has a probability of winning, let's say 80%. What is the probability that India will not win? 1
Okay.
minus probability of winning, which is what? 1 minus 0.8, which is nothing but 20%. This is what complement rule is.
Okay. Yeah. Thank you.
Okay? So probability of not something happening is 1 minus probability of that thing happening. Now the next question is, two dices are rolled together. Okay, there are two dices which we are rolling together. What is the probability that one has a number greater than 2? greater than 2 and other has number less than 4. Can you solve it?
I think 1 by 3, both of them occurring together.
Uh, 24 by 36.
So first event is 4 by 6, right? Greater than 2 means 4 by 6
Right.
into
Mm-hmm.
less than 4 is 3 events. So 3 by 6.
Right. You're right. Okay. So probability of getting a number greater than 2 on dice 1 and, and the number should be greater than 2 is 4 by 6, right? Probability of dice 2 and number less than 4, right? Less
3
than
by
4 is
6.
3 by 6. Okay. So probability of both the events happening at the same time, let's say event 1 and event 2 will be 4 by 6 multiplied by 3 by 6, 2 by 3 multiplied by 1 by 2, 1 by 3. Okay.
So the first, right, 4 by 6.
Mm-hmm.
How
Right.
how it
So,
is the
right. So in total, there are like 6 events which can happen in a dice, right?
Yeah.
So in total, 6 events are there. And now, how many are greater than 2? These 4.
okay?
So probability will be total number of favorable outcomes 4 divided by total number of outcomes 6.
Okay. Yeah. Thank you.
Sure. Okay. Um, okay, let's move on to the next question. Um, okay. So let's say there are multiple vacancies in a company. So there are like, let's say a lot many vacancies are there. There are multiple vacancies in a company. And let's say both husband and wife are applying for the job. Okay, I will not write full sentence, it will take time. So let's say both husband and wife apply for the job. Husband has a probability of getting selected. Let's say probability of husband getting selected is, let's say 1 by 7. Probability of wife getting selected is 1 by 6. Okay. Now you need to find out what is the probability that at least one of them will get selected. Okay. what is the probability that at least one of them will get selected? Hmm. No, Vinay, that's not correct.
One by 36.
1/6, you said?
36.
No.
1/7.
I don't think so. No, no, not 6/49.
2/7.
So it should be like, probability of both getting selected.
No, at
One
least
minus
one of them.
probability of both get selected.
No, that's also not
Oh,
correct.
okay.
You're thinking it right, but what you said is wrong.
Both of them not getting selected.
Yes,
They
it
gonna,
is one
yeah,
minus probability of both of them
Uh,
not getting.
not get is 2 by 7.
Yeah, that's correct. Do you guys need more time, or should I stop?
so is it like, one minus, then again one minus 1/7 into 1/6? Is that correct?
Mm, mm, are you getting 2/7? Like 2/7 is the answer.
Okay. I
The
haven't
probability,
calculated, and this is the logic.
Okay.
I have a doubt. Like the probability of husband and the probability of wife getting selected are related, right?
Mm-hmm.
So if we do this, like probability of husband or wife, So probability of husband plus probability of wife minus probability of both husband and wife.
Very nice. Yeah, that's one way of
So
solving it.
yeah, then the probability of husband and wife should be together will be like probability of husband
Mm-hmm.
into probability of wife with respect to husband.
Right, nice. Yes.
So when we solve that, it will be like probability of wife with respect to husband will be 1 7. Okay.
Okay.
So here,
So, okay, just 1 minute, right? So let's say we said probability of, let's say, husband getting selected or wife getting selected, right, will be probability of husband plus probability of wife minus probability of husband and wife, right? This is what you said,
yes.
right? So let's solve it and then we'll see like why maybe it is not working, right? I have not solved it, but let's try to solve it. Probability of husband 1 by 7, probability of wife 1 by 6, minus probability of both getting selected. What is the probability of both getting selected? Multiplication of 2, right? 1 by 6 multiplied by, oh, sorry, 1 by 7 multiplied by 1 by 6. So it will be
Why we
6.
have why we have multiplied 1 by 7 into 1 by 6 when they are related, like PA
They
into
are,
PB
they are
protein,
not related, right? Why
like
they are related?
because if they aren't like if one is gets selected, the chances of the other getting selected is less. Is like
No, no, it's not
so.
like that. That's why I put up, there are like a lot of vacancies
Okay,
are there.
okay, okay,
So,
yeah, okay, okay, okay.
okay, so these are independent events, right? So
Like
if
yet
I,
both of them will have the equal chance to select, right? Husband and wife.
no, no, let's say it's just take it as this. Let's say I'm giving an interview and there's a 1 year experienced guy who is giving interview, right? So if we both will appear for the interview, will we have the same chance of getting selected? Answer is no, right? So the skill also matters. So like everyone has a different set of skills. So here, let's say for example, maybe husband is having lesser skills as compared to the wife because husband has a lesser chance of getting selected as compared to the wife. It can be based on the experience, it can be based on the expertise in that domain and all of that, right? So they will not have equal chance. Okay, now I was saying that first of all, do we want to continue with this? Let's say this is 6 by 42 plus 7 by 42 minus 1 by 42, which is what? 12 by 42, which is what? 6 by 21, which is 2 by 7. Right? Done it right? Right? Have I done it wrong? Anything like all calculation is right, right? Uh,
Calculation is
Yeah.
right.
yeah, okay. 2 by 7. Right? So this is one way of solving it, obviously. What is another way of solving it? Let's just solve. Rub it. The another way of solving it is, let's say if I had not, if I was not attending this course, I will tell you how I would have approached it, to be very frank. If I was not attending this course, I would have approached it in this way. That there are 4 possibilities. Husband will get selected, wife will not get selected. Let's say this bar represents not. Husband gets selected, wife will not get selected. Husband will not get selected, wife will get selected. Husband and wife both will get selected. Husband not get selected, wife will also not get selected. Let's say these are the possibilities that I have. Okay, so what is the possibility that husband will get selected and wife will not get selected?
1 by 7 and 5 by
By
6.
7 minus into 1 minus 1 by 6.
6.
Right. Yeah, exactly.
3 by 6.
Okay. Probability of husband not getting selected will be 6 by 7 multiplied by wife getting selected 1 by 6. Husband and wife both getting selected, 1 by 6 multiplied by 1 by 7 multiplied by 1 by 6. Both not getting selected. Sorry. Okay. So it will be uh, 6 by 7 multiplied by 5 by 6. And these are all my favorable, out of, not all my favorable outcomes. Out of this, this is my favorable outcome, this is my favorable outcome, this is my favorable outcome. Okay, so I will add all of these. I will get okay. So we will get 5 by 42 from first one, plus 6 by 42, plus from third one 1 by 42, which will be 12 by 42, which will be again 6 by 21, which is equal to 2 by 7. So this is one way of solving it. Okay, or the other way of solving it, which will be a little bit modified.
Why 5 by 6?
This one 5 by 6.
Yeah.
Right. So this is 5 by 6 because I'm saying husband getting selected and wife not getting selected. Okay. So what is the probability of wife not getting selected? 1 minus 1 by 6. Right. 1 minus 1 by 6 will be wife not getting selected, which is nothing but 5 by 6.
Okay, got it.
We can also do this with both of them getting, like, neither of them getting selected, then
Mm-hmm.
subtract it from the whole possibility of one. Then we also get like 2 by 7,
Right.
at
Exactly.
least one. We're
Right.
gonna just like take it from that.
Mm-hmm. Right, that's correct, right? My next thing was, let's say, for example, if I have multiple possibilities and I don't want to do addition, subtraction, and all of that, I would have just thought of like, okay, actually, let me delete this slide, bring it back. So instead of, let's say, doing all of this addition and all of that, I can just use the complement rule and I can say that, the probability is going to be 1 minus probability of husband not getting selected and wife not getting selected. Okay, both will not get selected. That is 1 minus probability 1 minus 6 by 7 multiplied by 5 by 6, which will be directly 2 by 7. Right? Multiple ways to solve the same question.
Hello, here at least one of them will be selected means either it should be wife should select or husband and both of them three
Right,
conditions, right?
right, right. Okay. Any question? If not, we'll move to the next part. Right. Now we will discuss another rule that we conveniently skipped last time. That was this one. Probability of A and B is equal to probability of A multiplied by probability of B given A, or we can say that probability of B multiplied by A given B. Okay, we will first try to drive this whole thing, and then we will further use this to solve questions. Okay, now okay, let's say this is a Venn diagram. This is the probability of someone who loves eating candy, and let's say this is the probability of someone who loves drinking soda. Okay. Now, let's simplify it. Instead of candy or soda, we can just simply say math and English, right? So this is the probability of someone who loves math. This is the probability of someone who loves English. Now I will populate different numbers. There are 4 students who loves only math. They do not love English, right? They just like math. There are 2 students who like math and English both. There are 5 students who only like English and they do not like math. And then there are 3 students. Who are these 3 students?
Don't like
Who
anything.
don't like
Don't like
anything.
anything.
Right. They do not like math, they do not like English, right? So this is how, let's say, our Venn diagram will look like. Now let's put it in a table format. Same thing. So what are the possibilities? I love math. I love English. Or no, sorry, my bad. My bad. Either love math or I don't love math or like math. Okay. The next possibility is I love English, and another possibility is I don't love English. Now tell me what will be the number here, first of all.
5, 2.
2.
If they are
2
both 2.
love.
This number will be 2, right? The number of students who love both math and English, right? It is 2. What is the number of students who love English but they do not love math?
5.
5.
Number of students who love math but they don't like English.
4.
And this one, the last one, the students who don't like anything.
3.
3.
Okay. Now let's try to solve few simple questions. What is the probability that someone love math? Simple question, right?
2 by 7.
2 by 7. Probability of loving math. If you will randomly select a student, what is the probability that he will love math?
2 by 14.
Mhm.
2 by 7.
Okay, how many students love math? Okay, how many students love math? So,
4.
1 by 7, 4.
total number of students who love math is 4 or 6?
6.
6.
6.
6.
2
It
plus.
is 6, right? This much.
6 by 14.
Hmm. Right? These are all the students who love math. Okay. Although there are like 2 students who love English as well, but total number of students who love math is 6. So 6 divided by total number of students. How many students are there?
14.
12. 12. 12
Hmm.
students.
14 students, no?
14.
14.
6.
But 6. Okay, okay, yeah, yeah.
So 14 students. That is 3 by 7. Okay. Similarly, if I will ask you what is the probability someone love English?
8 by 14.
7 by
10 by
14.
14.
1 by
7 by 14.
Okay. 7 by 14. Which is equal to 1 by 2, right? And what is the probability someone love math and they love English?
2 by 14.
1 by
1
7.
by 7.
1 by 7.
Any doubt so far?
I didn't get how we get the 3. Don't love English and Max.
Love, okay, this one, right? Yeah. So the students who love both math and English is how many? 2, right? This middle part, right? Or here, let's say this part.
Okay.
This it. They love math as well, love English as well. Divided by total number of students, that is 14. So 2 by 14.
He asked 3. 3.
Mm.
How we get the 3?
Where is the 3? This one.
In the box.
This one.
Yeah, yeah.
This 3 is same as this 3. It was already mentioned here. Outside this, right? Like this is the circle, let's say, where student love math. This is circle where they love English. Outside is where they don't love any like math or English. It is 3. Okay, now another question. What is the probability that students love math or they love English?
Eleven by 14.
11 by 14, okay. Mm-hmm. Any other answer?
Sector 7.
5 by 14.
5 by 14, okay.
11 by 14.
7 by 14. 1 by
11
2.
by 14. Right.
1
Yes,
by
right?
2.
1 by 2.
Yeah. No, 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 not 1 by 2. So loving math or loving soda. So loving math will cover all of this region, right? And then loving soda, or it's or condition, right? So it means this as well. So the total will be 4 plus 2, that is 6, 6 plus 5, 11. 11 by 14.
But we need to include that three also, right? Because they also don't like maths and English.
No, but the question is they should either like math or they like English. At least
Okay.
one of them.
Yeah, Puneet, you mentioned in the formula that you have to minus the P of A into B. So
Right, right. That's a different way. Like right now, I'm just looking at the numbers and then solving it, right? Now, like as you suggested, I can do it this way as well. I can say that this is equal to, let's forget about this for now. This is probability of A plus probability of B minus probability of A and B. That is probability of liking math plus probability of liking English minus probability of liking both math and English. What is the probability of liking math?
Six
6 by
by
14.
14.
Plus probability of English, liking English,
1 by 2.
yeah,
Or
7
7
by
by
14,
14. 7 by
minus
14.
liking both,
2 by
right? So if you solve it, it will be 6 plus 7, that is 13 minus 2, that is 11, 11 by 14.
Okay.
Okay. Now, next to the next part, let's try to understand this terminology that we will be using in the next formula, which is given, right? Probability of someone loving math given they love English. Okay. What is the probability of someone will love math given that they love English? Given that they love English means that you already know that the person loves English. Then what is the probability that he also loves math? Right? When it is given to you that he already loves English, it means that you are already here. This is your universe now. He said it is given to you that he loves English. So it means that he is from somewhere here. What is the probability that now, like given that he loves English, what is the probability he loves math?
2. 2 by
2 by
2 by 7.
2 by 7, right? Because that person is already saying that you love English, so there is no, like, he cannot be from like here. I already know that he is out of these 7 students. Out of these 7 students, how many love math? 2, right? Similarly, if I will ask you, what is the probability that someone love English given that they love math?
2 by 6.
2 by 7. 2 by 6.
6.
4 plus
What will be the answer?
2 by 6.
2 by 6.
1 by 3.
3 by 6.
Yeah. So it will be more or less like, let's say when I say that, he loves, math, he is already in this region. When we say that he loves math, he is already in this region. Now I'm saying that if he loves math, 6, what is the probability that he also loves English? That is 2. That is 1 by 3. Fine. You guys are being able to follow what we are doing. Right? So this given part is represented using this line. This is given, that it is told to you that this has already happened. Okay. Now, uh, you know,
Can you please explain once again?
yeah, sure. So probability of someone loving math that they love English is 2 by 7. How? When I say that given that they love English, it means that they are already from out of these 7 students. They are already out of these 7 students. Out of these 7 students, tell me what is the probability that someone will love math? That is 2 by 7. Right? Similarly, when I say that probability of loving English, given that he loves math, given that he loves math means that you already know that he loves math. So I will not be, I will not be looking for that guy here. These 8 students are out of my universe now. Okay, these 8 students are out of universe. These 6 students are in focus. Out of this 6 student, what is the probability someone will love English? That is 2 by 6.
Okay, okay. So that the later part, in the first case, loves English is the universal case. So out of that, we need to select the students loving maths.
Right. That's
Okay,
correct.
okay, got it. Yeah.
Okay. Now, let's talk about this same thing of loving, let's say, math, given that you love English. Probability of loving math, given you love English, is what? What we had calculated?
2 by
So
7.
2 by 7.
probability
right? 2 by 7, right? So this 2 by 7, can I also write it in this format? Are these two same? Can I divide numerator and denominator by the same number?
Yeah,
Yes.
yeah, we can. It cancels out each other.
Right. And what is 2 by 14?
Variable outcome divided by total
Both
outcome.
loving English and loving math. Huh?
Yeah, very nice. Right. So 2 by 14 is nothing but the people who love both English and math. So 2 by 14 will become probability of loving math and loving English. Is that correct?
Yeah.
Yes.
What is 7 by 14?
People
Probability of
loving
loving
English.
English.
P of
Probabil
E.
probability of loving English. Okay. If I have to rewrite it, so I'll rewrite it like something like this. Probability of loving math, given that you love English, is same as probability of loving math and loving English divided by probability of
English.
loving English. Right? If I will write it in a more generic format, it will be like probability of A given B is same as probability of A and B divided by probability of
B.
B or A?
B.
B,
B.
right? Probability of B. Or I can write it as probability of A and B is same as probability of B multiplied by probability of A given B. Right? This is the same format you will see here as well. Probability of A and B, like we have written this part. This part we have written. Right? So probability of A and B is same as probability of B multiplied by probability of A given B. Okay, this is called multiplication rule. We will see how we can use it. And obviously, you can write it the other way around as well.
Can
Like,
you explain it? Actually, I disconnected the previous screen before this formula. This
after this,
like how we written this 2 by 14 and 7 by 14.
yeah. So I was saying that 2 by 7 is same as 2 by 14 divided by 7 by 14. Okay, because we can divide the numerator and denominator by the same number and it will remain the same. Okay. So 2 by 7 is same as 2 by 14 and divided by 7 by 14. What is 2 by 14? 2 by 14 is probability of loving math and loving English. Okay. Similarly, what is 7 by 14? 7 by 14 is probability of loving English. Okay. If you look at this one, this is 7 here. Loving English 5 plus 2. So 7 by 14 is that. Now I wrote probability of loving math given that you love English is same as probability of loving math and loving English divided by probability of loving English. In a generic format, it will look like this. Probability of A given B is equal to probability of A and B divided by probability of B. If you will rearrange it, you will get this. Okay, and let's try to prove the other way around as well. So it will be a practice also for us. Now I'm saying that instead of saying this, let's talk about probability of loving English given that you love math is equal to
Two by six.
1 by
By 6. 2 by 6. 1 by 3.
2 by 6, let's say. I'll do the same thing. 2 divided by 14. 6 divided by 14. What is 2 divided by 14?
The total loving both English and
Maths and English.
math. P
Right,
of A union B, A and B.
right. Love math and love English. And what is 6 by 14?
People loving math. P of A. P of B.
Love math. Okay. Same thing. What I will do is I will write it here. Probability of loving English given that you love math is same as probability of loving English and loving math divided by probability of
Maths.
loving math, right? So let's say last time I had called loving math as A. So this time I'll do the same thing. So loving English is what?
B.
B, right? So B given A is equal to probability of A and B divided by probability of A, right? Which will become probability of A and B is equal to probability of A multiplied by probability of B given. Right, so these two are same equation more or less. This one and this one, just the different format. Right? How I remember it is, right? Like, see, always find a way, of remembering things, right? Like, for example, what we used to do when we were in school, right? When we were in school, to remember things, we used to make like a few songs related to it, right? Or few rhymes, something, right? So similarly here, what I try to remember is that whatever it is starting with, it will end with the same thing, right? So the B is sandwiched between A. Similarly here, if you look at it, it is starting with B, so it will end with B. I remember it like this. So both A on the outside, B in the middle, or B on the outside, A in the middle. Okay, any way you want to remember it. Now we know that probability of A and B is same as probability of A. You guys tell me what it is. Probability of A multiplied by probability of
B
B.
by A.
B given
B
A.
given A.
B given A. Okay. Similarly, probability of A and B is also equal to probability of B multiplied by
Probability of A given B.
A given B, right? Again, just remember, if it is starting with A, it will end with A. If it is starting with B, it will end with B. Okay. So now we have these two conditions. Okay. Obviously, if the left hand side is same, I can equate the right hand side also. So I can say that probability of A multiplied by probability of B given A is same as probability of B multiplied by probability of A given B, right? Which I can rewrite to probability of B given A is same as probability of B multiplied by probability of A given B divided by probability of A. Okay, and this is a very famous equation called Bayes theorem. Okay, this is called Bayes theorem. Okay. Now let's try to any question on this before we move to the next part, like solving question related to this.
So is this just another, I mean, we have calculated the multiplication rule using P of A and P also, right?
Hmm.
And this is just the other way of calculating the same thing, right?
Right. Yes, more or less.
So in which case do we decide that we have to calculate using this formula or that formula?
This formula, and what is the other formula?
That probability of A and B is just probability of A into B.
Okay. So see, if someone will ask you to find out what is the probability of A and B, right? And you know these two, then obviously you will use this formula. If someone will ask you, no, I am not interested in probability of A and B. What I'm interested in, probability of B given A.
Okay.
Then I will use this formula, right? When I will solve question, it will become more clear.
Okay.
Okay. Now let's solve one question. Okay. Now I am telling you from my side that this question will require the application of Bayes theorem. Okay. What is Bayes theorem? We will rewrite it. Probability of B given A is same as probability of B multiplied by probability of A given B multiplied by probability of A. I'm telling you this formula will be used in this, right? Given that I'm telling you this, can you try to solve this question yourself? I will give you like 5-7 minutes. It's a little difficult question. I won't deny that. Okay. But give it a try so that when I will explain it to you, it will become like much more clear. So give it an attempt from your side once. I don't think it is 14%, right? But let's see. We'll try to calculate it. Maybe you are right. I think it is 14%. Yeah, you're right. So first, let's define what this question is. 10% of the patients in a clinic have liver disease. Okay, fine. 5% of the clinic's patients are alcoholic. That is also fine. Among those patients diagnosed with liver disease, right? 7% are alcoholic. So first of all, it's so much. So let's start writing it down. Let's just assume, having a liver disease is A. So what is probability of A? What it is?
5%.
1 by 10.
10%, right? 1 by 10.
10%.
I'm assuming that A is my event of, let's say, of a liver disease.
Liver disease.
Probability of B, let's call it probability, B event is nothing, that someone being alcoholic. What is the probability that someone is alcoholic?
5%.
5%. So let's say 1 by 20.
Yes.
Okay. What is the next part given to us? Among those patients diagnosed with liver disease, the people who have liver disease, 7% are alcoholic. it means that the people who have liver disease, that is given to you. So it means that B is given to you. A given B, right? A given B. Yeah, you're right. You're right. My bad.
B given A.
Right. My bad. Probability of B given A, that is probability of being alcoholic, given that you have liver disease, is how much? 7%. That is 7 by 100. Now you are interested. Yeah, tell me.
Sir, sorry, one question here. Among those patients diagnosed with liver disease, 7% are alcoholic means
It
the
means
patients who have both liver disease and as well as alcoholics, right? So it should be A intersection B, no?
no. It is not that. It is saying that among those patients who are diagnosed with liver disease, it means that the patients who have liver disease, 7% are alcoholic, right? So of all the people who have liver disease, out of those people, 7% are alcoholic. This is what they are saying.
Okay.
Okay. So among those patients diagnosed with liver disease, you are right that this 7% will have both liver disease and alcoholic. They will be alcoholic, right? But so it's more like this. What should I say? Randomly putting a few numbers. Let's say this is 80, this is 20, and this is what? 30, right? So if I will ask you, what is this common portion out of the total? It will be 20 by 130,
Yeah, 20 by 130.
right? But if I will ask you, let's say, if this is given to you, this is given to you, what portion is this 20 of total?
20 by 80.
20 by 100.
20 by 100. Yeah.
Right, 20 by 100, right? So this is not given to you. This is like in the question, this 7% is not this. The 7% is 20 by 100. This is given to you.
Okay. Yeah.
Okay, that's why it is a little different. So this is 7 by 100. Now what they are asking? They are asking, what is the probability? You are interested in knowing the probability of patient having liver disease. Like what is the probability that someone will have liver disease given that he is alcoholic? So what they are interested in is probability of finding A given B. This is something that I want to know. Okay, so what it will be?
Miss,
Let me
I
write it.
didn't get how you get the B given A.
B given A is given here. Among those patients diagnosed with liver disease, the people who have liver disease, 7% are alcoholic, right? So it means that 7% is what? 7 by 100. So of those patients who have liver disease, so it means that given that they have liver disease, what is the probability of alcoholic? 7 by 100.
Like we get the same answer if we write in the formula.
Which formula?
Like probability of alcohol and liver by probability.
Which one? This one? This one you are referring to?
No, there is another formula, right? Probability of A given by B.
That's one I'm writing it now. Let me first solve it. Maybe if you have any question, you can ask me after that. Okay. So probability of A given B will be probability of, yeah, I forgot. A
Probability of A
multiplied by
given B.
B given A, right? Same digit alphabet should be outside, and divided by probability of B. Okay. Now, which is same as probability of what we want to know? Having a liver disease given that he is alcoholic. what is the probability of liver disease given someone is alcoholic is same as probability of liver disease multiplied by probability of alcoholic given he has liver disease divided by probability of what? Probability of alcoholic. What is the probability of liver disease?
10, 0.1,
1 by
0.1.
1 by 10, right? What is the probability of alcoholic given that he has liver disease?
0.70,
7,
0.007,
7 by 100. I'll keep everything as fraction now. What is the probability of being alcoholic?
0.05.
5%.
Right. So it is 1 by 20, which will be same as 1 by 10 multiplied by 7 by 100 divided by 1 by 20, or let me put it into 5 by 100. 5 by 100. So this 100 and this 100 will get cancelled out. So it will become 7 multiplied by 10 into 5. Yeah, it is 7 by 50, which is same as 14 by 100, which is same as 14%.
Direct.
Okay, the same as 14%. Okay, this is same thing. This is equal to this, and this is equal to this. Okay. And then this is this. This is this. Okay, can we move to the next question? Let's try to do a simple question now. Then we'll do one more question on Bayes theorem. Okay. Let's say there are two bags. Two boxes sitting in a dark room. There are two boxes sitting in the dark room. This is box 1. This is box 2. In box 1, there are 5 white balls and there are 10 blue balls. Okay, there are 5 white balls, there are 10 blue balls. In the second box, there are 5 white balls and 5 blue balls. Now the question is, in both of these boxes are kept in a dark room, right? So you go into that room, select a bag and you draw a ball from that bag. What is the probability that the ball is blue, right? So one bag is selected at random. And a ball is drawn from it. What is the probability that the ball is black? What is the probability that the ball is black?
Okay, so we need to count all the balls first. That is 15 plus 20, 25. 15 plus 10, 25. Then out of 25 balls, we need to select the black balls. That is 15. 15 by 25. So probability of selecting box one or out of one box out of two is half. Right? So 15 by 25 into half. 15 by 50. That is 30 by 100. 30%.
Maybe right, maybe
7
wrong.
by
This was
12.
like it was a little difficult to follow. Maybe 7 by 12, right?
7 by 12, 58 point.
Okay. Okay, everyone try to solve it. Okay, okay. We will solve this question, but after this question, let's solve another question actually. This question reminds me of another question. There are 100 red marbles and there are 100 blue marbles. Okay, there are 100 red marbles and there are 100 blue marbles, and there are two bowls. Bowl 1, bowl 2. Now you need to distribute these 100 red marbles and 100 blue marbles in these two bowls in such a way that if one bowl is selected at random, okay, and one marble is drawn from it, the probability of selecting a red marble is highest. Okay, I will write it down. Distribute the 200 marbles, right? We have 200 marbles, right? 100 red marbles, 100 blue marbles. Distribute the 200 marbles between two bowls in such a way. This is not exactly a probability question. It's more like a puzzle. In such a way that if one bowl is selected at random, and one marble is drawn from it, probability of selecting red marble is highest. Okay, so note down this question. We'll take a break. Note down previous question as well, right? Like I can share only one screen, so maybe take a photo of this one, take a photo of this, right? Whatever, and then we'll take a 15-minute break. Try to drink water, get fresh. Think about these two questions. We'll come back and we'll first solve this question, and then we'll solve the second question. Okay, take a photo of it. I will keep this on for 1 minute and keep the other one on for another 1 minute. Okay, think about this question. If you're not being able to solve it, that's fine. But at least think about it. This one and the other one. Okay, and I will see you guys after the break. Okay, we'll start in 30 seconds. Okay, any like anything that you guys want to suggest? Like what should we do in this case?
Like in the normal scenario, like even if we like put equally 50-50, right?
Mm-hmm.
So what I thought to put like the whole hand, like one of all the blue balls in like one ball,
Mm-hmm.
and like all the red balls except from one, because it's gonna increase the probability of that ball of getting red.
Okay.
So
So
I like
yeah,
use
so
a
you
kind of trick, I guess.
so you are
We just
saying
wanna like increase the probability of red, right?
right, yes.
So we can
Okay.
just put all red in one ball, or except from like with one or two blues. So red
So you're,
ball is gonna be higher in
so,
that ball.
so you're saying that, let's say hypothetically 99 red balls here plus
Uh,
one blue ball, or let's say blue balls, let's say one blue
yeah,
ball.
something like that. Yes.
Okay, and let's say here 99 blue plus one red, right?
Yeah. Yeah.
Okay. Any other? Let's say if I'll start with this. If I'll start with this, that I have 100 red balls here and 100 blue balls here, what will be the probability of selecting a red ball?
50%.
50%, right?
Yes.
What if I will change the mix? Let's say maybe keep 50 as red, 50 blue, and here 50 red and 50 blue. Then
Then we can just take the probability of red from ball one, red from
mm-hmm,
ball one, then like 50 by 100 plus 50 by 100, like 100 by 100, 1.
no, you said 50 by 100 plus 50 by 100, so 100 by 101. Okay, I got it. Yeah, but that's not correct. Mm-hmm,
Yes, that's not correct.
mm-hmm,
So here also like a ball for ball it is 1 by 2.
mm-hmm.
Within it is 1 by 2. 1 by
Very
2
nice.
into 1 by 2.
The
Right.
total will be 1 by 2
So
only.
1 by 4.
Mm-hmm.
1 by 4, I guess. 1 by
No,
2.
no. So you're right. It was 1 by 2 multiplied by 1 by 2 plus
1 by
1
2.
by 2 multiplied by 1 by 2.
Multiply by 1 by 2.
So it will be one totally 1 by 4 plus 1 by 4. That is 1 by 2.
1 by 2, yes.
Can we increase the probability? Like for example, this scenario also we are getting 50% probability. Can we increase it?
Maybe we can just put one red ball in bowl one and
Mm-hmm.
remaining in bowl two.
Okay.
So we
So
can combine the number of marbles of blue color and the remaining of the red color in bowl two and keep one of them in one red marble in the bowl one, and the probability for bowl one would be one by two into 1 by 2, which will one into 1 by 2, and again the second one would be the remaining is 99 out of 100. 99 would be red and the 100 would be blue, so total would be 199.
Right. So
So
you guys
the
are said.
probability which I have tried to calculate is 1 into 1 by 2 plus 99 by 199 into 1 by 2. Which is giving me around 74.87%.
Nice, yeah, that's the right answer actually. So what she's suggesting is that maybe we will keep one red marble in bowl one and remaining all the marbles in bowl two. Okay, so the probability of selecting bowl one is 1 by 2. And what is the probability that I will draw a red marble from it? 100%, right? Plus, if second bowl gets selected, then what is the probability of drawing a red marble is 99 by 200. For simplicity, we will keep it, let's say 100 by 200, right? So it will be 1 by 2
It will
plus
be
1 by
99 by 199.
199.
Yes,
Yeah,
1
you are right. Be 99 by 199. Approximately, I'm keeping it as 1 by 4, right? So this will be approximately 75%, which is definitely way more than 55%. So 50% that we were getting earlier. Now, using the same thing, go back to this question and think how can we solve this question? What will be the answer to this?
If you apply the same, I did the same logic. I applied the same logic here. So here, if I consider selecting bowl one will be 1 by 2, and bowl two would be 1 by 2 again. And if I draw a black ball from bowl one, bowl one would be 10 by 15, it will be 2 by 3, and in the second ball it will be 5 by 10. which
Mm-hmm.
will be 1 by 2. So the answer that I'm getting is around 58.33%.
Right, nice, right? So this will
I also
become
got 7 by 12. Yes, I also got 7 by
7
12.
by 12. Okay.
Yeah.
So it will be 1 by 3 plus 5 by 20, right? Yes, so it will be 20 plus 15, that is 35 by 60. That will be 7 by 12. Okay, correct?
Yes.
Can you please explain the other one? This one is clear.
The previous one?
Yeah, this one.
Yeah. Okay. Here what we are keeping is we are keeping one marble in bowl 1 and we are keeping all the remaining marbles in the bowl 2. Now, because there is only one marble in the bowl 1, if you will accidentally select bowl 1, the probability of selecting a red marble from it is 100%, right? So 1 by 2, 1 by 2 into 1, because it is 100%. So it's more like 1 by 2 into 100 by 100. Okay. So plus 1 by 2, if the second bowl gets selected, then it is 99 divided by 119, 99. Why 199? This is total number of marble, 100 plus 99.
Yeah.
So if approximately, it will be 75%.
Okay, in the second ball also we are selecting red marbles only.
Yes, right.
Okay.
Like this is the highest percentage, right? Selecting the red ball from a box.
Sorry?
This is highest percent.
Sorry, there is a lot of background noise from your side. I'm not being able to.
Right.
Hello. Sorry, your question is not clear to me. Can you message me if you don't mind? Okay, so for this one, the answer is the answer is 7 by 12. Okay, let me ask you now another question. Same question. Okay, so we have two boxes, box 1, box 2, same distribution of marbles. Now, the question is, one ball is drawn at random, one box is selected at random, one box is selected at random, and one ball was drawn from it. Drawn from it. What is the sorry. If the drawn ball is black, what is the probability that bag 1 was selected? Okay. Now the question is little twisted. I'm not saying what is the probability of that the black ball will be drawn. It's the other way around. It is telling you, they are telling you that the drawn ball was black. Now, what is the probability that I had selected box 1? or bag 1?
Puneet, can you explain the previous ball question? Like I'm confused a little.
Yeah, this one. Yeah.
Yes.
So in this, there are only two possibilities, right? Either this box will get selected or this box will get selected. Let's first talk about the probability if box 1 was selected. The chances of box 1 getting selected is 1/2. Okay. Then chances of, let's say, drawing a blue ball from it is 10/15. If box 2 was selected, then the chances is 1/2. And if box 2 was selected, then the chances of drawing a black ball from it is 5/10. Okay, if you add these two events, because uh, uh, you know these are totally independent iterations. So if you'll add these two, you will get 7/12.
Can we use equal to probability, like selecting box 1 is equal to 2, right?
Sorry, probability of what?
Probability of selecting a black ball from box 1 is equal to this probability of black ball from box 2.
Why? Why?
Like, I'm just asking, can we do in that way?
No, but it is not. No, the probability of drawing a black ball from box 1 is not same as probability of drawing a black ball from box 2. So I didn't get the question.
For this question, like I got 4/7.
Okay, maybe you are right. I'm not sure. Don't know the answer yet.
So we have to apply Bayes' theorem here. Again, it is the continuation of the previous question. And the answer is 4/7.
Oh, 1/3.
But I got dropped out for a second. I'll share my screen again. Okay, let me tell you. This question you are supposed to solve using Bayes theorem. Okay, try to apply this thing that the probability of B given A is same as probability of um, probability of B multiplied by probability of A given B divided by probability of A. This question will be solved using this. Now think about it.
4/7.
4/7. Okay, nice. Now we have two people who got 4/7. 2 votes for this.
So 4/7 for me too.
Mhm. Okay. Let's think about it. Uh, Probability of B given A is same as probability of B multiplied by probability of A given B divided by probability of A. Now here we will what it is asking us. It is asking us what is the probability that bag 1 was selected or box 1 was selected given black ball was drawn will be same as the probability of drawing black ball multiplied by probability of this one black ball if box 1 was selected divided by probability of selecting box 1. Is this correct? Is this format making sense to you?
Yes.
Right? What is the probability of selecting a black ball if box 1 was selected?
10 by 15.
Is it 10 by 15? Is this correct? If box 1 was selected, probability of selecting a black ball is 10 by 15 because there are 10 black balls in box 1. What is the probability of selecting box 1?
1 by 2.
1 by?
1 by
Yeah,
2.
1 by 2.
1 by 2. And what is the probability of drawing a black ball?
Probability of black box in box 1.
No.
Then
What is the
probability of
probability
1 by
that
2.
a black ball will be drawn?
15 by 25.
15 by 20.
It will be 7 by 12.
7 by 12.
What is the probability that a black ball is drawn? It was 7 by
7
12.
by 12.
Okay. So
How,
it will
sir?
be
Can you please explain me? Probability of
probability of drawing a black ball, the previous question,
okay.
right? Like we discussed in the previous question that if one bag is selected at random and a ball is drawn, what is the probability that the ball is black? So it is asking you what is the probability of ball is black? 7 by 12, right? Now if I have to solve it, it will be same as 7 by
Okay.
12
So when
multiply.
we say that probability of black, we need to consider selecting it from box 1 and box 2, right?
Right, both.
Okay. I thought
Okay.
only box, total box.
Yeah. So it will be 7 by 12 multiplied by 2 by 3 multiplied by 2 by 1, I believe, right? This will become the reciprocal. So this will become 7 by 9. Is that correct? Uh, is it 7 by 9? Just check once. Just 1 minute.
Yeah, 7 by 9 is coming.
No, I've done it wrong. I've done it wrong.
It should be
Yeah. I'll just change it. So if your probability of bag 1 given black ball was same as probability of bag 1, the bag 1 will be on top. This is what I've done wrong. This will be
Sir,
probability of
actually,
bag.
it is probability of black ball given that back one is chosen, right? It is that way.
Yeah, this one. Yeah, this one is probability of black ball given that bag 1 is chosen. You are right. But it will get multiplied with bag 1 probability. And probability of drawing a black ball will be in the denominator. Right? So like if it is B given A, then B comes first, probability of B. So probability of bag 1 given black ball, it means that the probability of bag 1 will come on top. Is it making sense to you guys or not? Like, are you guys being able to follow what I'm doing? Because I made a mistake last time.
So what we actually like calculating in this, first we are like evaluating the probability of whole bag one. If we like, I want to visualize it. We should have the probability of bag one, and within it we like multiply it by like multiplication rule to get the probability of black ball from box one. Then we divide
Mm-hmm.
by the whole probability of black that we have calculated 7 by 12.
Okay, no, let me actually write it like in a more neat manner from a news sheet. First of all, probability of B given A, right, is always probability of B. Whatever come first here will come first here also. Probability of A given B divided by probability of A. Last time I wrote the formula wrong. That is one thing. Now, what it is asking me, I will try to write it in a more detailed way so that it is more clear. Probability, let's say, what is asked in the question? If the drawn ball is back, so this is given to you that the drawn ball is back. What is the probability that bag 1 was selected? So the first part is bag 1 selected, given that black ball was drawn. It is not probability of black ball. It is the probability of drawing a black ball. Okay. That if you will choose a ball, then it is black. It is same as probability of B. What is probability of B?
7 by 12.
Bag 1 getting selected is multiplied by probability of A given B. A given means the black ball will be drawn. Given that box or bag 1 was selected. Given that bag 1 was selected. Divided by probability of A. What is A? Probability a black ball was drawn. So probability of bag 1 getting selected is 1 by 2, right? What are the chances that the bag 1 will get selected? 1 by 2. What is the probability that a black ball will be drawn if bag 1 is selected? If it is given to you that I have selected bag 1, then what is the probability that the black ball will be drawn from it?
10
What it will
by
be?
15.
10 by
15,
15.
right? 10 by 15. What is the probability if nothing is given to you? Just like simply, I have said that the same scenario, two boxes are there. One box has 10 black balls, another box has 5 black balls. One box is selected at random. What is the probability black ball will be drawn? That we calculated in the previous one. 7 by 12. So that will be 7 by 12. Okay. So 1 by 2 multiplied by 2 by 3 divided by 7 by 12, which is same as 2 by 6 multiplied by 12 by 7, which is equal to, I still feel I've done something wrong. This is 7 by 12, this is 1 by 2, this is, right. We are doing it right. Then 4 by 7. This is 4 by 7. Okay, which you guys said here.
Can you please remove that 7 by 2 in the earlier slide?
Uh,
Slide 1 by 2.
which
This is correct only, right? 1 by 2.
this is yeah, this is correct.
Okay, okay.
Puneet, I had one query.
Mm-hmm.
Do we really have to practice numericals on these theorems or on these concepts to have a hands-on?
Yeah, like yes. Otherwise, for example, just saying it. Let's say if I had just told you that this is Bayes theorem, right? And if you'll not practice this, then I don't think we will be able to grasp it to that level, right?
So even after the class,
Hmm.
can we get any assignment from your side, or should we practice it offline via internet and Google Help?
Yeah, that will be, I think, the best way to learn anyway, right? Just simply Google questions on Bayes theorem. You will get 3 or 4 questions, and you can solve it and you can practice it.
Okay, okay. Thank you.
Okay, yeah, sure, no problem. Okay, now, so yeah, so this will be 4 by 7. Anyone has any question, let me know. Otherwise, we will move on to the next part. The next question, last question for today.
Like Puneet, I have a question. Like, if we get any problem, like how we can analyze the solution? Like, is there any steps?
How can we?
Analyze the solution.
What is unlike?
Analyzing the solution, I'm saying. Like this is like these
Mm-hmm.
scenarios. Before applying any formula, we need to think, right, what will happen, how the
Right, right. So
probability will be.
that actually comes with practice, right? So, uh, like more you will practice, the more you will get to know that okay, this can be solved using that particular formula. Okay, without that, I think there is like without practice, it's not possible, right? In general, in real life, it will not be given to us that okay, we need to apply this formula. Like all of whatever we are learning today, right, is something that I hope that we will be applying it in our real life, like in our day-to-day life, when we will be, let's say, start practicing data science. So obviously, in your day-to-day work, no one will come and you will tell you that, okay, this is the formula that we need to apply over here. But what tool to use, which formula to use, which theory to use is something which comes with practice. Okay. For example, the next question that I'm gonna take will explain you, let's say, for example, where Bayes theorem can be used. So uh, let's take a step back and discuss, what happened at the time of COVID, right? Everyone remember COVID? I think it happened like just 4 or 5 years back. So at the time of COVID, there were two theories, I would say, which was out there, which was very contradicting with each other. And you guys need to tell me whether you also think the same or not. Okay. at the time of COVID, there were this COVID testing kits which was there. The people will take sample of you and then they will like quickly tell you in 5-10 minutes that whether you have the COVID or not, right? And the government was claiming that these testing kits are very accurate. Do you remember this? Or do you remember it being very inaccurate? How do you remember it?
It was like there was some like 1 or 2 or 3% of inaccurate rate.
Mm-hmm.
There was in all the machines. Like they were like not 100% correct, like 97,
Uh-huh.
98. So on the basis of that, we were going on like clinics and asking for the machine who had like better chance of detecting COVID.
Right, very
So
nice, right? So at the time of COVID, so I agree with you that the COVID testing kit that was there, that the government was using on stations, right, railway stations, bus stands, right, or any crowded area, they will test you and they will tell you whether you have a chance of COVID or not. And the government was saying that the this testing kit is like very accurate, 97, 98% accurate, right? And I believe that, right? And then there was a second theory also. Second theory is that I used to meet a lot of people, and it has happened with me as well, that the people got tested of COVID, all right, but they have no symptoms altogether. Or let's say when we test them again, the result was, let's say, negative. So there were a set of people who used to think that these COVID testing kit that we have are not very accurate. Have you guys ever heard of these kind of similar experiences?
Yes.
Yes, yes.
Right? So, which kind of creates a doubt in our mind that maybe these testing kits are not as accurate as what the government is claiming it to be. Like the government is claiming it to be 98%. And I know so many people like whose test was positive and they had no symptom. And I'm pretty sure if they will get it tested again, maybe they will come negative. Right? So it contradicts. Right? On one hand, I am saying that the testing kit is very accurate. On the other hand, I'm seeing a lot of people, which I believe have a false report, right? It means that their report is not correct. This is what I feel was happening. Okay. Then at that point of time, on LinkedIn, I saw a particular post, and I realized that how that post was related to Bayes theorem, right? So the same scenario, like the thing that the article that I read on LinkedIn, today I will be discussing it with you. Okay. So that guy was explaining that actually both the things are right. The people who say that the testing kits are not very accurate because they're seeing a lot of people who get tested positive and then they don't have any symptom. So most probably they don't have COVID. Those people are also not lying. Those people are also correct. And at the same time, when the government says that the testing kit has an accuracy of 98%, so the government is also not lying. The government is also saying the truth, right? But how this can be possible? Like how it is possible that the people who have wrong COVID positive result, they are also not lying. And when the government says that the testing kit is very accurate, that is also correct. So this is the contradiction that guy tried to explain. Okay. And that's something that we will discuss today. So what we will do is he tried to explain it using Bayes theorem. He said that, okay, let's assume, right? We have COVID test kit which is 98% accurate. Okay. We have a COVID test kit which is 98% accurate, which I believe is a very high accuracy. Okay. And let's assume that at a given time, 5% of India's population has COVID. Okay. So we have COVID testing kit, which is 98% accurate. And at any given point, 5% of the total population has COVID. If one person is selected at random, okay, if one person is selected at random and his or her test was positive, and if his or her test was positive, what is the probability that the person actually has COVID? Okay. So again, this is a real life problem, right? No one is gonna come and tell you that this is where you need to apply Bayes theorem and all, right? But that guy observed a scenario and he thought that maybe this is a question of Bayes theorem, right? Maybe no one is lying. Maybe everyone is saying the truth. It's just that let's try to prove using mathematics that even if my testing kit is 98% accurate, what are the chances that the person will actually have COVID if he get a test result, if his COVID test result is positive? Okay, so again here, I will try to apply Bayes theorem. What is Bayes theorem says? Bayes theorem says probability of A given B is same as probability of A multiplied by probability of B given A divided by probability of A. Okay. Can anyone tell me what is
B?
sorry. Yes. Thank you. Thank you. Okay. Can like I'm not asking you to solve the question, but can you at least help me writing this formula in words? What will be
B,
the
B is like positive test,
what is
and
the
A will
probability
be
of what
probability
is
of A is gonna be COVID.
COVID.
okay, probability of A is that
COVID.
someone has COVID
Given their test is positive.
test result is positive
Hmm.
equals to what is probability of A now?
Probability of
Probability
COVID
of
is
having COVID.
0.9, 0.05.
No, has COVID.
Has COVID, yes.
We need to write it in word first, right? What is B given A?
Probability having test positive, given that he is COVID.
Test
Positive.
will come as
Given that
positive
has COVID.
if someone has COVID.
Go to that of test result.
Divided by
Test result.
Test result is positive.
test result positive. Okay. Now, what is the probability that someone has COVID?
0.05%.
5%.
5%.
So
5
let's
by
call
100.
it 5 by 100, right? 5 by 100. What is the probability? This is also easy one. Second one. What is the probability that test will come positive if you have COVID?
0.98.
98. 98 by
98%, right?
Yes.
If you have COVID, the chances that your test will come positive is 98%. There's a 2% chance it might come negative. Because why? Because my testing kit is only 98% accurate. So 98% time it will give me the right result, 2% time it will give me the wrong result. Okay, now the last part. What is the probability that the test result is positive in general?
One by two, right?
Why 1 by 2?
Like either the test result is positive or negative.
No. Okay. That reminds me of actually very good question actually. Okay. What is the probability? Sorry for me saying this. What is the probability that you will die today? What is the probability according to you?
Not
Is
sure.
it Is it 1 by 2? Is it 50%
Hmm.
that you will die today?
No, like you
No,
can't
right?
be sure.
Yeah, I agree. I'm just asking about the chances. Is it 50% that you will die today? No,
No,
right? Because 50, but there are two possibilities. Either you will die or you will live. So why it is not 50%? Right? See, the total number of outcomes, favorable outcomes divided by total number of outcomes. Like what you have just done is you used a probability formula. What was the formula? The total number of favorable outcomes divided by total number of outcomes. Right? This is what you did. You say when you said
Yes.
50%, right?
Hmm.
But that thing is only correct when both the outcomes are equally likely. When the probability of both the things happening is exactly the same, then it is what you said is right. So, for example, a random person, the probability of dying is not 50%. I cannot say that there are two outcomes which are possible. One is either he will live. And this is the question that someone asked me, so I thought of sharing. So, there are two outcomes either you will live or you will die today, or you will be dead. So, if someone will ask me what is the probability that I will be dead today, it will not be 1 by 2. Because this formula is only true when both the things are equally likely. There is equal chance of both happening. But for a normal, healthy person, the chances of living is definitely way more as compared to the chances of dying on a given day. Okay, so the probability is not equal for live or for dying, and that's why it cannot be 1 by 2. Or let's say you can try to understand it from a example of train as well. If someone will ask you what is the probability that the train will, let's say we have Vande Bharat train, right? It is famous for being on time. What is the probability that the Vande Bharat train will come on time? Will it be 50%? Because either it will come on time or it will not come on time. Will it be 50%? No, right? Otherwise, every train will have a 50% probability of coming on time because either they will come or either will not come. I cannot solve this question like this. The reason being is both the outcomes are not equally likely. Vande Bharat train getting delayed versus coming on time is not equally likely. There's a high chance it will come on time. There's a low chance it will get delayed. That's why it cannot be 50%. Okay. The same logic I will apply here as well.
Okay.
That the test result of coming positive will not be 50% because both the events are not equally likely. Okay, so what are the chances that the results will be positive? Okay, now another question. In what scenarios the result will come positive?
when a person
If the person has COVID.
Right, that's right. And is there any other scenario in which the test can come positive?
When the
Yes, when you
person
don't
has
have COVID, 0.02% chance of like getting
Mm-hmm.
positive.
Mm-hmm.
I think there will be two chances, one with being with COVID and positive, and one with COVID without COVID and being positive.
Very nice, right? So we'll talk about test being positive. And there are two scenarios in which the test can come positive. Just like there are two ways in a drawn ball can be of black color. The first scenario is that you have COVID and at the same time, not plus, and test was right.
Yes.
The COVID kit has given me the right result.
Test was right as in test was positive.
Test was positive, or yes, test was positive.
Okay.
I'll tell you why I said right here. The other scenario is that you don't have COVID and test result was wrong.
Wrong.
The test result was wrong. Okay, now we will talk about both the scenarios. What is the so having COVID and test was right the probability of I am, selecting a COVID person is 5 by 100, and the test being correct is
98 by
98 by
100.
100. Or what can happen is that I have selected a healthy person
25 by 100.
and the test came
Into 2
wrong,
2
by
by
100.
100.
right? So let me solve it using my phone.
0.067.
0.05 multiplied by 0.98 plus 0.95 multiplied by 0.002. Okay, so it is 0.068. This is 0.068. So I will impute that value here. This is 0.068, right? Approximately 6.8%. Okay, now what I will do, I will impute all the values. I will impute all the values. So probability of having COVID that someone have COVID because their test, the COVID test was positive, is same as, I will multiply all the probabilities, 5 by 100, that is your 0.05 multiplied by 0.98, right? This is 98 by 100 divided by 0.068. Okay, so it will become, let's calculate, 0.05 multiplied by 0.98 is 0.049 divided by 68 divided by, this is approximately 0.72, which is equal to 72%. So although the COVID testing kit was 98% accurate, even then, if your test result comes positive, the chances that you actually have COVID is not 98%, it is 72%. Right? It means that approximately, right? Even if I will assume it, right? Like let's account for some error and let's assume it to be 75%. It means that 1/4 of the cases are wrong. 25% of the cases, more than 25% of the cases actually were wrong. When someone was getting tested positive, that doesn't mean that the person actually has COVID. 25% is a very big number, right? Especially
Just
when the government is claiming the testing kit is 98% accurate. Yeah, sorry.
by looking at the data, like it was like not like looking at like this is gonna be 75%
Mm-hmm.
because the numbers are very low, but still it's like coming to 75.
Mm-hmm.
So only like 5% of the population has COVID, and out of those also like there is like 75% chance. So okay.
Okay. No, so the thing is that it means that the but government said that the testing kit is very accurate, 98% accurate, right? And then I'm testing you and you are coming out positive. And significant number of people are saying that we don't think that we have COVID because we don't have any symptom. And I'm pretty sure if I'll do another test, most probably it will come negative, right? So why there was so many people like that? Because of Bayes theorem. Bayes theorem says that even if you have a very high testing accuracy, even then only approximately 70% of the people who will be tested positive will actually have COVID. The remaining 30% will not have COVID. Okay, even though the test result was positive, right? So no one is lying. The public is not lying when they say that their test result was positive and they don't think they have COVID. At the same time, the government was also not lying, saying that when they say that the accuracy is 98% of the testing kit. Okay, any question? Is it clear? Okay, any question? Otherwise, that's all for today. And I'll see you guys tomorrow. Cool. Thank you guys. Thank you for joining. Bye bye.
Thank you. Bye.
Thank you.